Hello, is everything visible and audible? Is the board visible? And am I audible? Am I audible? Probably. Let's wait for a few minutes. Then we will start solving all the integrals. Actually, I had to cancel the last scheduled stream because probably there were some issues with the internet, I guess. That's why I'm streaming this again. And don't worry, I will put everything in the description. But for the time being, we'll wait for just a few more minutes and we'll start there. Okay, let's start. Okay, so the before starting the integrals, let me just do this particular thing. Now, why is this particular thing so special? There's actually nothing very special in this, but the thing that is special is if we try to solve this, we can just separate out both these terms. Now, once we separate both these terms, we will get this something like this. And since then, what is this particular function? This particular function is nothing but the GIF function. What is the GIF function? It's the greatest integer function. So the function of this particular function is to find the largest integer which is smaller than this particular x. So that is also the floor function. We also call it the floor function. And yeah, it's fine. So this particular function is a bit special function, and actually we need to solve this by taking certain intervals. We can't solve it directly. So in the integral from 0 to 1, the box of x function, this box of x function is actually equal to 0 because if x is between 0 and 1, then the largest integer which is smaller than x is obviously 0. So this is basically 0 plus integral from 1 to 2. Box function of x, if x is between 1 and 2, is obviously quite understandable. There is dx, is 1 dx. And this thing will continue till 9 to 10. And if x is between 9 and 10, then obviously the box function will be 9 dx. And what about this particular function? This is a pretty trivial one. Let's keep it for now. This is 0, this is 1, and we will actually, if we continue adding all these terms, we'll get something like this. And 2 by 5 integral of x is x squared over 2. This is from 0 to 10. And if we solve this, the summation from 1 to 9 is 45. The 2 and 2 will get cancelled out. We have x squared over 5. Now if we apply the limits, we will have 100 over 5. So 100 over 5 is basically 20. So it is 45 minus 20, which is 25. Well, that's basically the idea. It's a very simple one. Actually, there's no particular reason why I'm doing this particular integral, because after all, it's a definite integral, and by the title, it is I'm actually solving indefinite integral. Well, this is not a part of the list of the problems that I have created, but don't worry. After the stream is over, I will put all the questions in the description. You can check them out. So let's start with the integrals that we have. And please do correct me if I'm making mistake anywhere. Please do rectify my mistake. Okay. So the first question is, integral of sine x over sine of x minus alpha dx. Okay, so how can we solve this? This is a pretty trivial one. This particular integral came in 2004 AIEEE exam. This particular integral came in 2004 AIEEE. So how can we solve this? This is a very simple one. We can assume that x minus alpha is some t. So from here we can understand that x equals alpha plus t. And if we differentiate both the sides, we will have basically dt over dx as 1, because the differentiation of x is 1 and alpha being a constant, it is the differentiation of a constant is 0. So dt equals dx in this case. So we can basically write that this is the integral of sine of t plus alpha over sine t dt. Okay, so we can solve this particular expansion. Sine t plus alpha is sine t cos alpha plus cos t sine alpha. In the denominator we have sine t. We have dt over here. So after this we just need to see what are the things that are happening over here. The sine t plus sine t cos alpha over sine t is basically cos alpha, and cos t sine alpha over sine t is nothing but cot t sine alpha dt. Okay, let me write the things over here. So we have the integral. This thing is equal to the integral cos alpha plus cot t sine alpha dt. Integral of cos alpha is t times cos alpha, and sine alpha, we can, since this is a constant, we can take this out of the integral. So we have sine alpha times cot t dt. So t cos alpha. So what is t? Actually, we had assumed that t is x minus alpha. So we have x minus alpha times cos alpha plus sine alpha times the integral of cot t. And what is integral of cot t? Integral of cot t is nothing but natural log of sine t with a plus c over here. So the final answer is x minus alpha cos alpha plus sine alpha natural log of sine x minus alpha plus c. So here we have the first solution. Give me 1 second, I'll be back. Okay, so let's continue. Okay, so the next question is integral of dx over cos x minus sin x. Is everything visible? I think so. Okay, so let's continue. So the thing that we can try over here is dx over, let's multiply the denominator by half and multiply the numerator by half. This gives us cos x minus half. Okay, instead of half, just a second. It's not half, let's multiply root 2. So since this is a constant, we can take this out of the integral. We have dx over 1 over root 2 cos x minus 1 over root 2 sine x. Okay. Now, can we just do something with the denominator? You see very closely. This thing is basically sine of pi by 4 cos x minus cos of pi by 4 sin x. And 1 over root 2 dx. So what is this particular thing in the numerator? It's nothing but sine pi by 4 minus x, because the formula for sine pi by 4 minus x is sine pi by 4 cos x minus cos pi by 4 sin x. So from here we can get an idea that what is the thing actually going on. So we have finally the integral 1 over root 2 cosec of pi by 4 minus x dx, and the integral of cosec x. We can assume that this particular thing is some t. We can assume that this particular thing is some t, then dt over dx is minus 1. So dt equals minus dx. So we can just deal with the minus. So we have 1 minus 1 over root 2. Yes, this particular question came in 2004 AIEEE. This question came in 2004 AIEEE. Okay, so if we solve this again, we'll have cosec t dt. Now, what is cosec? What is the integration of cosec? Integration of cosec is basically log of cosec t minus cot t. And we know that what is t actually, it is pi by 4 minus 6. So I'm just writing that t is actually nothing but pi by 4 minus x. So if we just plug in, we will get the answer. So we're basically done with the second question. Nothing to worry, I will put all the questions in the description. You can have a look on them. After I'm done this stream, I will put all the questions in the description. So let's move on to the third one. Actually, I chose this particular time to stream because I will be a bit free at this time, because because the other time I need to get prepared with my studies. So this is the time when I can actually try these things out. So and that's why I can see that hardly any people are actually watching the stream, which is quite understandable also. So let's move on to the next question. Actually, it doesn't matter because the entire stream will be available. So the next question is integral of log x minus 1 over 1 plus log x squared whole squared dx. Okay, so what we can specifically do with this? We can see that log x is a pretty much disturbing thing over here, so we just assume that log x is some t, and so we can specifically do that t minus 1 over 1 plus t square whole square. And what is dt? This is a specific thing. Dt over dx is 1 by x. And what is x? It's basically e to the power t. So dx is e to the power t dt. Okay. So instead of writing dx, we can write this as a et dt. Okay, pretty much understandable. And so the next thing is also not a very problematic thing. Yes, this particular question came in 2005 AIEEE. This question came in 2005 AIEEE. And now we just need to apply by parts. So how can we apply the by parts? We need to assume that this particular function is the first function and this is the second function. So by parts, we know that this particular function needs to be the first function integral of the second function integral differentiation of this particular function. So differentiation might be a bit problematic over here, but let's do it separately. Differentiation of this particular integral, this particular expression is denominator squared 1 plus t squared minus t minus 1 times 2t. So if we solve this integral, or not integral, this expression, so we 1 t square minus 2t squared plus 2t t squared whole square. So this thing is basically 1 plus 2t minus t squared over 1 plus t squared whole square. Okay, so I'm really sorry, it's something like this. So the final expression looks something like this: t minus 1 over 1 plus t squared times this thing, which is 1 plus 2t minus t squared over 1 plus t squared whole square e to the power t dt. So is this helping at all? Please do suggest me, because I am probably attempting these questions for the first time. So please do suggest me. What we can do with this is turning kind of messy. Can we do something with this? Oh yes, I didn't notice this particular thing. It's actually pretty trivial after that. It was completely useless. If you see very closely, this is nothing but e to the power t. times expansion of this particular term. This is t square plus 1 minus 2t over 1 plus t square whole square. So what we can write after this, e to the power t, we can separate the things out. 1 plus t square whole square minus 2 times t over 1 plus t square square. If you notice very carefully, then okay, I'm sorry. If you notice very carefully, differentiation of this particular term is this particular term, and we know that the integral of e to the x of f of x minus f dash x dx is nothing but e to the power x f of x. Now, actually, we could have solved this by parts because this thing is proven by parts. We can do that particular thing, but that will be a bit messy. But this is a better way because we directly we can apply this particular result. We can prove this particular thing also by parts. So from here we get to see that this is the first function. This is this particular f of x. So we can understand that e to the power, the answer is e to the power of t over 1 plus t squared. And we know that what is t? T is natural log of x. So it is x over 1 plus log of x squared plus c. So we are done with this. Let's move on to the fourth question. The next question is, okay, the fourth question. Integral dx over cos of x plus root 3 sine of x. So this is quite similar to the question number 2. What we can do is divide the denominator by 2 as well as the numerator by 2. So what we get from here is a very simple question. This particular question came in the year 2007. This came in 2007. AIEEE. So it's a pretty decent question. It's a very simple question. We can see that this particular half and root 3 over 2. So we can particularly find a pattern over here. We can see that this is nothing but sine pi over 6 cos x plus cos pi over 6 sine x. This is 1 over 2 dx over. Hey Pranav, how are you? sine pi over 6 plus x. So this is, we can see that if we expand this particular thing, then we can find this. So again, we have cosec of pi over 6 plus x. We are assuming that this particular thing is t dt. Now why is this dt? Because if we differentiate this particular thing, this dx over dt will be the same thing. And we know that half times the integral of cosec of t. Now what is cosec of t? Cosec of t is nothing but natural log of cosec of t minus cot t. And what is t over here? T over here is pi over 6 plus x. I'm not writing this thing again because it will turn a bit messy, but let's keep it over here. So this particular question came in 2007. So we can see that more or less the questions are more or less easy, which were the AIEEE section for this particular integration. So let's move on to the next question. Question 5. Root over 2 times the integral sine x over sine sine of x minus pi by 4 dx. Hey Krish, how are you? So this particular question is quite similar to the extreme, the first question that we had done. It's pretty much the same question. Instead of alpha, we just have a particular value over here. So we are assuming that this particular thing is t. So clearly we can see that, let me write over here. We can see that dt over dx is basically the same thing. Dt and dx are basically the same thing. And so we can write that this is sine of t plus pi over 4 over sine t dt. Now again the same thing, expansion. Sine t plus pi by 4, it is basically this is by going, if we go by the formula, then this is the thing, over sine t. Oh, I'm sorry. So we have this integral. We can just remove this bracket, it is not useful. Go over to. So we can see that this particular thing, this is also very interesting. See, we can see that root over 2 and these root over 2's are actually getting cancelled. So we can just get rid of this root over 2's, all of the 2's. So we are basically left with 1 plus cot t dt. Am I doing it right? Yes, I guess. So we have t plus integration of cot t. So what is integration of cot t? Is nothing but natural log of sine of t. So t is this particular thing, x minus pi over 4. X minus pi over 4 plus the natural log of x minus pi over 4 plus c. I hope everything is visible. Is everything visible? But am I audible? Am I audible? Is there any kind of discrepancies going on here? I think everything is fine. I'm actually myself watching my stream so that just to check out that everything is fine. Okay, so let's continue. Hopefully everything is fine now. Let's continue. So this particular question came in the year 2008, again in AIEEE. So we can see that there are actually numerous patterns in these exams. This is really interesting. Okay, next question. Okay, so the next question is actually a very big jump. This is of 2019 JEE mains. So long we were doing AIEEE, and this is a big jump. I shouldn't have done this jump, but I just found it randomly. That's why I plugged in the particular question. There's no apparent reason for doing this. But anyway, it is not a very difficult question. It's 5x to the power 8 plus 7x to the power 6 over x squared plus 2 times x to the power 7. X squared plus 2 times x to the power 7 plus 1 squared plus 1 squared. Okay. So what we can do with this? This particular question came in 2019. So what we can do with this? Well, in this kind of questions where there are a lot of big numeric powers, we need to divide by something in the numerator and the denominator as well. So what if we divide x to the power, we divide the numerator and the denominator by x to the power 14? Well, there is a reason that why I'm dividing the numerator and the denominator by x to the power 14. There actually we could have chosen larger exponents, but there is a particular reason that why we are choosing x to the power 14. So we will be able to understand that why I'm choosing x to the power 14. Now, if we divide x to the power 14, the denominator will get 5 times x to the power minus 6 plus 7 times x to the power of minus 8. So the basic idea of doing this is we need to take this as t and we need to frame the numerator such that it appears as dt. So that's the basic idea. See, if we divide x to the power 14 in a numerator, we'll get x to the power of minus 5 plus 2 plus x to the power of minus 7. We can see that what is going on. If we take this particular thing to be t, we can see that dt over dx is minus 5x to the power minus 6 minus 7 times x to the power of minus 8. We can see the pattern over here. Now the only thing that we need to do is multiply negative sign in the numerator. Actually, it doesn't make any difference. It's more or less the same thing. So we can see that what is actually going on. Just a second. Okay. So if we take that this particular thing is t, if we assume that this particular thing is t, then you can see that the numerator is basically dt, and this is okay. The square is over here, t squared. So this is nothing but minus integral of t to the power of minus 2 dt, which is basically nothing but t to the power of minus 1. Let's see. Now, what is t? T is this particular thing. I'm just writing t. What is t over here? Just to avoid things getting messy. So this was 2019's question. Interestingly, this also came in 2021, I guess. I'm not sure, but probably I saw it somewhere that this particular question came in 2021 also. Yes, I mean, I'm doing this just because I will have ample amount of time of doing this. Because at this time, I generally go to sleep. That's why I will have ample amount of time now. Okay, so the next question. Give me a few seconds. I will be back. Okay, so let's get back to business again. Okay, so let's move on. Okay, so the next question is question number 7. That is integral 5 tan x over tan x minus 2. Again, quite similar to the previous question. We Since this particular tan x is being used a lot, so we are just assuming that tan x is some t. We will assume that tan x is some t. So we can see that this is 5t over t minus 2. Now what to do with this dx? Just differentiate both the sides. We'll see that dt over dx is nothing but root over 1 plus t squared. Okay. I'm sorry, it is 1 plus t squared. Very, very sorry. Because differentiation of tan x is basically sec square x. And just a second. Okay. So this thing, because differentiation of tan x is basically sec square x, and 1 plus tan square x is sec square x. So we know that dx is basically dt over 1 plus t squared. So if we write dx over here, we can see that this is 5t over t minus 2 times dx, that is dt over t square plus 1. Okay, some interesting stuff now. We can use partial fractions from here. So how to use partial fractions? We can just assume that this particular thing is of the form. So as we can see that there is no t square term in the numerator. The only term in the numerator is the coefficient of phi, the coefficient of t. So t is the only thing that will be remaining. So we see that a plus b is basically equal to 0 because a times t squared plus b times plus b times t squared is actually nothing but 0 because there is no t square term over here. The next thing we see that the constant term is also 0 over here. So we can see that a minus 2c is also equal to 0. And the only thing that is remaining is t. So from where are we getting t? Yes, obviously, ct. So c is actually equal to 5, which is quite understandable. Oh, I'm sorry, not c. We also have c minus 2b as equal to 5. Now it is quite understandable that a is basically minus b and a is 2c. Now we can plug in everything over here. We know that minus b is a, so minus 2b is actually nothing but c minus, okay, let me write it over here. So we have a plus b equals 0, or in other words b as minus a and a as 2c, okay, or c as a over 2. So if we plug in this over here, we can see that this is nothing but a by 2 minus 2 times b. 2 times b is how much? So basically this thing. So this is coming as 5a over 2. Because 5, 5 and 5 gets cancelled. We are left with a equals 2. Now if a equals 2, then b is obviously equal to minus 2 and c is obviously equal to 1. Now we can pretty much do everything because we know that what are the terms in this particular partial fraction. Okay, so this is t minus 2. Instead of a, we will plug in 2. Instead of b, we'll plug in minus 2. And instead of c, we'll plug in 1. And basically, we need to integrate this, which is again pretty trivial. Integration of this thing is nothing but 2 times the natural log of t minus 2 minus, we can just take the minus out of here. Let me drop this particular part. So if we apply this integral, then we can see that this is 2 times natural log of t minus 2 minus, again, natural log of t square plus 1. Why? Because if you assume this to be some p, then dp over dt will be 2t dt. So this is basically the reason why. And the integral of t square plus 1 is basically tan inverse t. So this is basically the answer where t is tan x. I'm not writing again tan x because it's quite understandable and it will make things messy. So I hope it is understandable. And please do rectify me if I'm doing mistake anywhere because I'm quite sleepy now. I'm not sure that whether I'm doing everything right or wrong. And I'm also seeing these questions for the second time, I guess. I actually haven't prepared these questions much. I've just seen the questions. So if I'm making mistake anywhere, please do rectify me. And if not in the live stream, then please rectify me in the comment section once I'm done with this particular stream. Then I can rectify my mistake. Okay, so we are done with question number 7. This particular question came in the year 2012 AIEEE. This was 2012 AIEEE. This particular question came in 2012 AIEEE. Okay, so let's move on to the next question. And the next question is a pretty interesting one. It's not the general indefinite integral that we have been solving so long. It's a bit interesting one. So far, we have seen pretty simple questions. These all questions are pretty simple and pretty doable. Obviously, they are a bit lengthy, also not very lengthy, but more or less it is okay. Okay. Next question, question number 8. I guess I will move over here. Just a second. Okay. Question number 8. The question number 8 says, if we have an integral of f of x, which is actually equal to some psi of x, we need to find that what is the value of the integral x to the power 5 x to the power 5 f of x cube. So what we can particularly do with this particular question came in the year 2013 AIEEE. No, it is not in AIEEE, this came in JEE mains. I'm sorry, 2013 JEE mains. So what we can do with this? Obviously, we are left with no other choice other than by parts. So what kind of by parts shall we do? We know that this particular integral exists. So we'll probably try to do something with this. We need this particular integral. And basically, solving this particular integral means that we need to get rid of this f of x. We need an answer which is in terms of this particular psi of x. So basically, solving means this thing. So what we can do is, okay, let's try. If we can assume that x cube is some t, then dt over dx is 3x squared. Okay, so we have plenty of x over here, so let's try to do something with this. So it's 3x squared x cube f of x cube dx. Now interestingly, this is t f of t dt. Things are getting really interesting here. So what we can do? Yes, we need to apply by parts. So let's apply by parts. 1 by 3 is remaining common over here. We need the integral of this particular function. So this function is definitely the second function. So this function needs to be the first function. Integral of this function is this function, that is psi of t minus the integral differentiation of t is 1, integration of this thing is again psi of t dt, and we are done because we have already got rid of f of x. So it's a pretty simple question. We just need to look for some patterns. It's a pretty simple question. We can just plug in xq over here and we can find out that what is the answer. And the options were also in this particular form, so we can quite easily check what is the answer. So this came in 2013 JEE mains. From 2013 JEE mains starts till 2012 we had AI. From 2013 we were having JEE mains, and uh, from now whatever question we will be seeing all are of JEE mains. Don't worry, I will put a link. I will put all the questions in the description once I'm done with the stream. Okay, so let's move on to the next question. Okay, so the next question is integral of 1 plus x, integral of 1 plus x minus 1 by x times e to the power of x plus 1 by x dx. Okay, so what we can do with this? What we can do with this? How we can try to solve this? So let's separate the things out. E to the power of x plus 1 by x dx plus integral x minus 1 by x times e to the power of x plus 1 by x. So whenever we have e to the power x, we have something e to the power x, then there can be two things. Either we need to use by parts. Obviously, we need to use by parts whenever we have e to the power of x. And whenever we are able to see that there is some e to the power x term in the integral, we can probably try of thinking this thing. Okay, so let's prove this, that why this thing actually holds. Why this thing actually holds. Let's try to prove this. Now, if we apply by parts, then obviously this is the last function, this is the second function, this is always a second function. So we have this as the first function. Minus integral differentiation of this particular thing. This is f dash x. Are we doing everything fine? Is everything fine? Is everything fine? Is everything fine? E to the power of okay. So if we're just applying the by parts. So while applying the by parts, what we can do? This is always a second function. So this needs to be the first function. And if this is the first function, then f of x minus f dash x times the integral of this function is e to the power of x minus integral differentiation of this is f dash x minus f double dash x times e to the power x dx. So can we do something with this? I guess I've made some mistake over here. It's the first function, and okay, we'll come back to this particular thing after we're done with this integral. So let's try this integral first, then we'll try to prove it. So what we can basically do, let's apply by parts over here. So this is the second function. This is the second function. This is the integral times x minus 1 over x minus integral 1 minus 1 over x square times integral of this. Just a second. We can solve this by parts, assuming this particular thing is the first function and integral of this thing exists. Is everything fine? Okay, if we are able to, just a second. If we separate the things out, please do suggest me if you have any ideas. Actually, I'm extremely sleepy now. Okay, just let's try to solve these things only. So if this is the first function, okay, instead of doing this, what about we just take x common out of here? So why is this important? This is because if we take x plus 1 over x as t, then the differentiation of this thing will be actually this times this. That makes things a bit simpler. That makes things a bit simpler. I'm extremely sorry. Actually, I'm actually feeling a bit sleepy now. But never mind. We will continue. Okay. Okay. What we can do with this? No, let's keep this aside for the time being. What we can do with this? Okay, just let's do this. X times 1 minus 1 over x square e to the power of x plus 1 by x dx. So now if we apply by parts, then this is the, let this be the first function, then we'll have something like this minus the integral. Differentiation of this thing is the same, and we are just basically having the integration of this thing again. If this is the if this is the first function, then integration of this thing is actually this minus. If we differentiate this, then we will have basically this thing. Yes, we are done. Now if you see that if we take this particular thing, then we're basically cancelling these things out, and we have, yes, so basically we're done. This particular question came in the year 2014 JEE mains. 2014 JEE mains. Okay. Yes, we were doing the by parts proof. Let's try to prove that by parts, a particular thing. We're trying to prove that particular thing. Let's try to prove it. Okay, I had actually done a very severe mistake. That is integral of e to the power of x f of x plus f dash of x. It's actually something like this. I've done a severe mistake, and actually no one spotted it. This thing is actually equal to e to the power of x f of x. This particular thing is actually equal to this. So we can prove it by applying the by parts again. Minus the integral minus the integral minus the integral of this thing. Differentiation of this thing. So what is the differentiation of this thing? Actually, we don't need the differentiation of this thing. Even if we need this, yes, we can. F dash x plus f double dash x e to the power x dx. F of x e to the power x plus f dash x e to the power x minus integral f dash x times e to the power x e to the power x dx minus integral f double dash x e to the power x dx. So, is there any problem? Is there any kind of problem? Just a second. Yes, 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 yes. I don't think there should be any problem. And even if there is a problem, then okay, let's try to do it in this way. We have f of x, then okay, just let's just try to separate the things out. Let's just try to separate the things out. We have f of x times e to the power x. Okay, that's fine. And what else do we have? Okay. So it's a very, really sorry. Okay. So let's assume that this is e to the power x, f of x plus e to the power x, f dash x dx. So we can solve this integral by parts, that is f of x times e to the power x minus integral f dash x e to the power x dx, and we have integral of e to the power x f dash x dx. So this thing and this thing are getting cancelled. We are left with f of x e to the power x. So this is basically the proof. I was just a bit confused between what is going on. Okay. So I think that considering this thing to be true, I have already done a mistake in question number 2. So let's try to do question number 2 again. I think I have done a mistake over there. Let's try to do question number 2 again. So the question number, not the question number 2, question number 3. So let's try to do question number 3 again, where it was shown that we had log x minus 1 over 1 plus log of x squared dx. So we are assuming that log of x is t, then dt over dx is 1 by x, that is 1 by e to the power of t. So we can see that dx is basically e to the power t dt, and then integral t minus 1 over 1 plus t squared dx. It is e to the power t dt. Okay. So if we expand this, we have t squared plus 2t minus 2t plus 1 over 1 plus t squared whole squared dt. And so we have integral e to the power t squared plus 1. This is over nothing but 1 over 1 plus t squared minus 2t over 1 plus t square whole square dt. Okay, so obviously differentiation of this thing is this thing. So is there any kind of mistake? There shouldn't be any kind of mistake. Let me check the question again. Just give me a few minutes. I will just check the question once more. I'll just check the question and let you go. The question should be correct. The question is correct. Please do pardon my mistakes. Actually, I'm doing this for the first time, and also I'm a bit sleepy. So I might do a lot of mistakes. Okay, so instead of directly applying the formula, what if we just apply by parts over here? We have e to the power t 1 over 1 plus t squared minus 2t over 1 plus t squared whole squared dt. What if we apply by parts directly over here? Integral e to the power t 1 plus 1 plus t squared minus integral e to the power t times 2t over 1 plus t squared dt. E to the power t is the first function, is the second function. This is basically the first function minus integral differentiation of this. Oh yes, obviously, because we are differentiating this. Obviously is the same thing. This is the same thing. Yes, I was a bit confused between the signs. Yes, obviously this is the same thing only. This is the same thing. I was a bit confused with the sign. Yes, this is the same thing only. This is the same thing. So yeah, we didn't do actually any mistake. I actually did a mistake in writing the formula. Instead of plus, I wrote it minus. Please forgive my mistake. Okay, so we had done up to 9. Let's move on to question number 10. Please do pardon my mistakes. Question number 10. Integral dx over x squared x to the power 4 plus 1 3 over 4. So we have something in the power 4. So what if we just take out this x to the power 4 out from the denominator? We have x cubed 1 plus x to the power of minus 4 to the power of 3 by 4. So we'll try to do a bit fast now. If I make mistake, please rectify me. I know I am a bit sleepy actually. Anyways, assuming that x to the power minus 4 is some t, so we can see that dt over dx is minus 4x cubed. X to the power minus, I'm very sorry. Very sorry. Oh, I'm very sorry. I actually did a mistake over here only. So 5. So this is minus x to the power 4 times x to the power of minus 5. So we already have x to the power minus 5 over here. The one thing we require is minus 4. So we just multiply minus 4 and divide by minus 4. So integral minus 1 by 4 dt over 1 plus t to the power of 3 by 4. Okay. So it's a pretty trivial thing now. 1 by 4. It's minus 3. It's minus to the power of minus 3 by 4. So by the rule of integration, it's basically by 4 plus 1, that is 1 by 4. And this thing. I guess the minus sign will be there, or will it be? And t is basically nothing but x to the power minus 4. This particular question came in 2015 JEE Mains. Let's move on. Question number 11. I'll try to do a bit faster. Question number 11. Integral 2x to the power of 12 plus 5x to the power 9 over x to the power 5 plus x cube plus 1 whole cube dx. This particular question came in 2016 JEE Mains. Okay, so what we can do from here, let's take out 5 common for x to the power 5 common from here. So if we take x to the power 5 common from here, we'll have x to the power 15 in denominator, and so we will be having plus 5 into x to the power of minus 6 over 1 plus x to the power minus 2 plus x to the power of minus 5 cube. Interestingly, if this is t, then you can observe that this particular thing, entire thing in the numerator is basically dt. Because differentiation of this thing is this and this thing is this, we can just multiply minus sign over here. We are having dt over t cube, that is minus, the minus sign will get cancelled out. T to the power minus 3 is t to the power minus 2 over 2, and t is 1 plus x to the power minus 2 plus x to the power of minus 5. Okay, let's move on to the next question. That particular question, actually, a particular mistake, I did a very severe mistake in the sign. I made a very severe mistake in the sign. My apologies for that. Okay, next question is, what is integral tan to the power 4x dx plus integral tan to the power 6x dx? So what we can do from here? We actually have no ideas to what to do with these things. So the only thing is, we need to somehow apply sec square x. What we can do? Let's first try to integrate this particular function. We can separate out tan square x times tan square x. Instead of writing tan square x, we can write sec square x minus 1. Instead of solving this, what if we solve this? What if we solve this? Tan to the power 4x times sec square x minus 1 dx. So if we solve this, we will have tan to the power of 4x sec square x dx minus integral of tan to the power of 4x dx. So if we just basically add this thing, you can see that this thing and this thing is getting cancelled, and this is the only thing that is remaining. That is basically t to the power of 4 dt, something of this particular form. This is basically t to the power 5 by 5 plus c. And what is t? This is tan to the power of 5x by 5 plus c. This particular question came in 2017. This question came in 2017 JEE Mains. Nice. Okay, let's move on to the next question. Question number 13. Let's move on to the next question. That is question number 13. So question number 13 says, we have this integral sine square x cos square x over sine to the power 5x plus sine cube x cos square x plus cos cube x sine square x plus cos to the power 5x whole squared. Oh my god, what kind of sum is this? We have so many terms in the denominator. Let's try to factor them. Sine square x cos square x. What if we take sine cube common from this thing? So let's take sine cube x common from the first two things. So we'll have sine square x plus cos square x, that is basically 1. And if we take cos cube x common from here, we will having sine square x plus cos square x, which is basically 1 again. So we will have this. Okay, we have sine and cos combination. So what can we do in case of sine and cos combination? Yes, we can try to convert everything in the form of tan. So how can we convert everything in the form of tan? Let's try to divide the numerator and the denominator with cos to the power 6x. If we divide the numerator by cos to the power 6x, we will be having tan square x sec square x. And if we divide the denominator, we will be having tan cube x plus 1 squared. Okay, pretty trivial. Now, just we need to solve this. We can assume that tan x is some t, so we can see that t square over t cube plus 1 squared dt. If we assume t cube as another some p, we can see that if we differentiate t cube, we will be having 3t squared. So just divide the numerator with 3 and divide it by 3. So we will be having nothing but just a second, 1 by 3. If we assume this thing to be a particular term, then this entire term will become, we have 1 minus over here, t cube plus 1. Now what is t? T is tan x. Please forgive me if I'm making mistake, and please do rectify me. Even if it is not in the live stream, then hi Divendra, how are you? And if I'm making mistake anywhere, please do rectify me. And even after the live stream is over, you can rectify the mistake in the comment section. Rectifications are always welcome, and if I'm making mistake anywhere, please rectify me. It's an earnest request. I might make mistakes because I'm extremely sleepy now. But anyways, I will try to complete the 25 integrals that I have collected. So let's move on to the next question. The next question we have is, okay, so the last question came in the year 2018. The last question came in the year 2018 JEE mains. The last question came in the year 2018 JEE mains. So let's move on to the next question. The next question is question number 14, integral of sec 2 by 3 x cosec 4 by 3x dx. Okay, okay. Sec, it is basically cos 2 by 3 x, and cosec is sine 4 by 3 x dx. Again, we have some sine and cosines combinations, so we can probably try to do something with tan. Okay, since we have 1 by 3 common, so let's write it in this manner. Cos square x sine to the power 4x 1 by 3. Now what if, this is in power, now what if we divide the numerator and the denominator by cos square x? This will be sec square x dx, and if the cos square x enters this thing, then this will be cos 6x. So yes, so this will be basically 10 to the power 4 by 3x. Yes, we're done. So this is basically nothing. This is a very simple thing now. 4 by 3 dt. So what we can do with this? This is nothing but we just need to add 1, that is 1 by 3 minus 3. I guess it's fine. Plus c, and here t is tan x. So I guess it is more or less okay. And this particular question came in the year 2019. Okay. So we are done with question number 14. Let's move on to the question number 15. Let's move on to question number 15. All the questions which are after the year 2013, after the year 2012, are all JEE mains questions, and all the other ones are actually the questions from AIEEE. There is actually AIEEE got converted to JEE mains actually. Otherwise, there's nothing much difference over there. Question number 15. I guess we have done question number 14. Yes. Okay, so question number 15 says we have the integral dx over cos cube x root over of 2 times sine 2x. Okay, so what we can do over here? What we can do over here? Sine 2x is basically, so this is cos cube x root over 2 times. So we can just take out 2 common here because we know that sine 2x is basically 2 sine x cos x. So if we just take out 2 over here, then we can see that we will have 4 in this under root, so we can take out 2 common from here. So we'll have something like sine x cos x. Again, we have sine x cos x combination. Can we do something with tan? Let's try. Let's divide the numerator and denominator by cos square x. Sec square x dx cos x over sine x cos x. Let's put this thing inside. Sec square x dx, and if we just take this thing inside, this will be squared, and if this is squared, then it will be basically sine x cos cube x. Is there any problem? Any problem? I guess there is some kind of problem. Okay, never mind. Let's divide things again. This time by, again, let's divide the things again by cos square x. Okay. So if we divide the things again by cos square x, that will be 1 plus tan square x times sec square x over, if we divide the things by this, then we will be basically having root over root under sin x times cos cube x. This cos cube x will get cancelled out, so we will be having tan x. So again, we can probably deal with it. This half times the integral 1 plus t square over root p dt. Okay, pretty simple now. Half times, okay, just let me write it over here. basically have half times integral 1 over root t plus t to the power of 2 minus half. 2 minus half is how much? 2 minus half is 3 by 4. 4 dt. Okay, so half times t to the power of minus half. T to the power of minus half is t to the power of half, and if we divide it by 2, then we are basically done with this, plus half times t to the power of 3 by 4, that is basically t to the power of 7 by 4. 7 by 4. Please do rectify me if I'm making mistake. I don't know the answers. I just plugged in, I just took the questions and I'm solving it. I'm not sure that whether I'm doing it right or wrong. Please rectify me if I'm doing wrong in the word. So what is t? T is 10x. Please do rectify me if I'm making mistake anywhere. Okay, I don't think I made a mistake over here. The idea is basically more or less the same. Okay, okay. So this particular question came in the year 2016. This particular question came in the year 2016 JEE mains. Okay, let's move on to question number 16. Question number 16. So question number 16 says, integral x times the root over 2 times sine of x square minus 1 minus 2 minus sine of minus sine of 2 times x square minus 1 over 2 times sine of x square minus 1 plus sine 2 times x square minus 1 dx. So again, a pretty simple question. Why is it simple? Because we can see that it is sine of 2 something. So if we simply expand this square minus 1, it will be 2 sine x square minus 1 cos of x square minus 1. Nice. Okay. 2 sine x square minus 1 minus 2 times sine of x square minus 1 cos of x square minus 1. I hope everything is visible. I will literally cry if the video is not visible, if the stream is not visible and I am not audible. I will literally cry because I'm extremely sleepy. I don't know how long I can continue. I hope I will complete it very soon. So we can see that we can actually cancel all the sine of x square minus 1 from the numerator and denominator. So what are we left with? X of 1 minus all the 2's as well. It's a plus sign in the denominator. Cos of x square minus 1 dx. So we can assume that x square minus 1 is some t, then dt over dx will be 2, so we can just multiply this. We can do this. So 1 minus cos t over 1 plus cos t dt. Now what is this thing? This is actually tan of t by 2. Why is it tan over t by 2? Because we can write cos t as 1 minus sine square t by 2. So if we subtract this, then we'll have sine t by 2 in the numerator, and if we add this, then we will have cos t by 2 in the denominator. So this is basically half of tan t by 2 dt. We already have half over here, so there is no problem at all. And tan of x is basically minus natural log of cos of t by 2. Now what is t? We have assumed that t is x square minus 1. So we can plug in over here and we can solve it. So this particular question came in the year 2019. This is a 2019 question. Okay. So let's move on to the next question. Where is my marker? There it is. Okay. So the next question is, this is which number question? This is question number 17. Just 9 more. Integral dx over 1 plus root x 1 plus root x root over of x minus x square. Okay, so what we can do here? Let's see what we can do here. So since we have something in the root, let's assume that root x is some t. Then yes, we can obviously try that out. dt over dx is basically 1 by t. It's basically 1 by t. So let's see. Dx is t dt. I'm sorry, it is 1 by 2 dt. It's 2t dt over 1 plus t squared, because it is no, it is not t squared, it is 1 by t root over of t squared minus t to the power 4. Now interestingly, we can cancel out t squared from here, because if we take t squared common from here, then it will be t, and this t will get cancelled out. So 1 minus t squared. Okay, so let's try to factor the things out. 2 dt over 1 plus t root over of 1 minus t times 1 plus t. So what we can do over here, integral, yes, obviously we can try this out. 1 minus t plus 1 plus t over 1 plus t root over 1 minus t square dt. So what is this basically? If we take this out, it is uh, root over of 1 minus t over 1 plus t root over of 1 plus t plus dt over root over 1 minus t square. Okay, so what we can do over here? What we can do over here? Uh, I guess everything is fine. Just a second. Let me write it in a fresh manner again. It's actually becoming a bit clumsy. So let me write it again. Integral. We've assumed that this particular thing is t. So 2t dt with this t actually is getting cancelled. So 2 dt over 1 plus t times 1 minus t square. Okay. Okay. So we tried this thing, that is 1 minus t plus 1 plus t over 1 plus t root over 1 minus t squared dt. So if we write it like this, then we will have root over of 1 minus t over 1 plus t root over of 1 plus t dt. Okay. uh, okay. The next thing is pretty trivial. So will this particular thing help? Not much sure about it. uh, I'm not much sure about whether this entire thing will help me anyways. Can we do something over here? This entire thing might not help me at all, but I'm not sure much about it. Uh, just give me a few seconds to understand. Uh, I hope I'm not making a mistake anywhere. Hopefully, I'm not making a mistake anywhere. Well, I'm not sure. Did I write the question correctly? Just a second. This must be correct. I don't think there is any problem here. Please give me a few seconds. I'll just check whether the question is fine or not. Uh, yes, the question is fine. Okay. Now, what if, what if instead of trying these things, what if I take this to be t, dt over dx? Maybe this is basically the same thing, only a bit more modifications. So what if we take this to be t? Then 1 by 2 times root over x, which is basically t minus 1. So 2 times t minus 1 dt is dx. Actually, need to get. Okay, so let's just plug this in. It's 2 times t minus 1. 2 times t minus 1 dt over. This is entirely t. And what about this? It's 1 minus. We can just take our t from here. Just a second, I'm sorry. What we can try over here is x minus x squared. It's not x minus x squared. I'm very sorry. It's x squared minus x to the power 4. X squared minus x to the power 4. Hopefully, I'm correct. Let me just check the question once more. No, it is x minus x squared. I'm very sorry. X minus x squared itself. Okay, so let's do something more. We can take x common from here. We'll get 1 minus x. 1 minus x is basically what it is. It is nothing but 2 times t minus 1 over t times x. X is t minus 1. X is basically uh, okay, it is t minus 1 squared because root x t. So x is basically t minus 1 squared. So it is t minus, yes, we are done. It's actually working. So t minus 1 squared, and if it's t minus 1 squared and 1 minus x and 1, but what is 1 minus x? 1 minus x is 1 minus t minus 1 squared. So that is basically what it is. And if you just take this out, t minus 1 thing, you will have left 1 minus x. So what is basically 1 minus x? 1 minus t square minus 1 plus 2t. So it is 2t minus t squared. So this thing and this thing are getting cancelled. And we are left with 2t minus t squared dt. Is it even helping? Not sure. Not sure, not sure, not sure. Not very much sure regarding the thing. Just give me a few more seconds. Uh, okay, what about uh, okay, this is basically nothing but 2 dt over t times root over of 2t minus t squared, isn't it? So what if we take t square common from here? Yes, I think it will work. If we take t square common from here, we will be having 2 dt over t square root over of 2 over t minus 1. So now it's pretty much evident that what is actually going on. We are basically now having, is everything visible? Is everything visible? Yes, yes, it's visible. So now we can see that we have 2 dt over t squared over 2 by t minus 1. Assume this, that 2 by t is some p, then dp is nothing but p minus 1. So this is nothing but uh, yes, 2 times root over p minus 1. And what is p? P is 2 over t. Now what is t? T is 1 plus root over x. Okay, kind of tired now, but yes, we will complete it anyways. When is the thumbnail integral? Actually, I had to cancel my last stream because probably there were some glitches. I'm not sure that what kind of glitches there were, but I had to cancel the last scheduled stream, and that's why I started a new stream again. So, okay. So this particular question came in 2016. This particular question came in 2016 JEE mains. I'm really sorry, everyone, if I'm making a lot of mistake and I'm taking a lot of time. I understand because I'm actually feeling extremely sleepy now. My brain is actually working at a very slow pace now. I'm really sorry for that. I'm really sorry for the inconveniences. But that's the fun. If you can't solve the problem, you keep on trying that, and with other people, if you can discuss these problems, then what is more fun, like what is more fun? That's a really interesting thing. If I take the random questions and try to solve it on the spot, make mistakes, ask everyone, ask for the suggestions, that's interesting. So the next question is f of 3x minus 4, 3x minus 4 over 3x plus 4 equals x plus 2. So we are given this particular function. We are given this particular function, and we are asked that what is integral f of x dx. We are asked that what is f of x dx. So one thing that we can do is, okay, so this question came in the year 2017. This question came in the year 2017. Okay, so what we can actually try to do is we can write this particular integral as f of 3x minus 4 by 3x plus 4 d 3x minus 4 over 3x plus 4. The basically what the thing that I'm doing is I'm replacing x by 3x minus 4 over 3x plus 4. That's basically the entire idea. Now we just need to get rid of this big thing. So how we can do this? There is d 3x minus 4 over 3x plus 4 over dx. So what is this thing actually? This thing is basically 3x plus 4 squared 3 times 3x plus 4 minus 3 times 3x minus 4. Okay. Okay. So 9x is getting cancelled with 9x. So there is 12. 12 plus 12 is 24. So this is basically 24 dx. Okay. So from here we can see that we have, now this thing is basically x plus 2. 24 over 3x plus 4 squared dx. Now basically it's very simple now. We just need to apply the, we can solve it by partial fractions, or we can just do anything with this. This is very simple. Let's write it down. We just basically need to solve this particular integral. This is a very simple integral now. X plus 2 over, you can just take out the 24 out. We have 3x plus 4 squared dx. Okay. So what we can do? We can just make the numerator look like the denominator. So we can basically multiply 3 inside. So we had 24 outside, so this is basically 8. This is 8 times the integral 3x plus 4 over 3x plus 4 squared plus 2 3x plus 4 squared dx. I think everything is fine. Hopefully everything is fine. 24 3x plus 4 was there, and I guess it's fine. Yes, it's fine. Okay. So this is very simple after this. This is basically nothing but natural log 3x plus 4. Okay. Plus 16. The integral of this 16 by 3 into minus 1 over 3x plus 4. Probably I'm correct. Probably. I'm not sure. Is it everything fine? Is everything fine? Uh, might be. Might be. I think it's fine because we just need to have a 3 over here. So we're just dividing by 3 over here. And we have the denominator. And yes, it's fine. This is fine. So this question is done. Let's move on to the next question. The next question is also quite similar. It's almost similar to this question itself. So I'm just solving it in a faster way. Okay. It's said that f of x minus 4 by x plus 2 is 2x plus 1. Okay, we need to find the integral of f of x dx. So basically the same thing, f of x minus 4 over x plus 2. So we can write it like 2x plus 1 and d of x minus 4 by x plus 2. So what is it actually? Is 4 over x plus 2 is basically x plus 2 squared x plus 2 minus x minus 4. So this is basically 6. This is basically 6 dx. Okay. So 2x plus 1 x over x square dx. Again, it's pretty similar. The same thing basically. Okay. So we have integral 6 times 2x plus 1 over x plus 2 squared dx. So we need to do the same thing basically. Since we have x, so we can basically take 2 out from here. This is 1 by 2. So we can write as 3 integral x plus 2. We can write it as x plus 2 minus 3 by 2. So this is something like minus, sorry, not minus, plus 3 by 2. Yeah, minus 3 by 2. Sorry. Minus 3 by 2 over x plus 2 squared dx. So this is 3 times the natural log of x plus 2 minus 9 by 2 x plus 2 c. Yes, probably. Please tell if I'm doing a mistake anywhere. I might do mistake. It's 2:40 in the morning at my time. Okay, so let's move on to the next question. 20th question. We're almost done. We're almost done. Okay, the last question came in 2018. The last question came in 2018 JEE mains. The last question came in 2018 JEE mains. Okay, so the next question is integral x plus 5 root over of 7 minus 6x minus x squared dx. Okay. Okay. So what we can do over here? Again, we can take x squared common from here. So if we take x squared common from here, we will be having plus 5 over x. Instead of x, can we take something else? Or will it help? I don't think this will actually help much. Instead, if we take x to the power 4, let's see what happens. If you take x to the power 4, then it will be 2x to the power minus 1 plus 5x to the power of minus 4. Sorry, it's not minus 4. It will be minus 2. But will it help after all? Not sure. What if I take x to the power 6 common from here? X to the power 8 probably might not help me at all. What we can take common from here? What we can take common from here? Uh, what we can do with this? Okay, let's keep this aside. I don't think that we can take anything common from here will help. Taking anything common from here, I don't think it will help. Let's try something different. Okay, what if this will be 2x plus 6 over 7 minus 6x minus x square. This will be fine. Dx over root over 7 minus 6x minus x squared. Yes, this will be fine. So this is again to the minus 5. So this is 7 minus 6x minus x squared. So why is it so? Because if we take this term as p, then dp over dx is actually this thing. You can check it out. Yes, obviously minus m is there. Very sorry. Minus m is also there. And this thing, so this is not a very difficult thing. We can just arrange the denominator as a perfect square. Can we write 7 plus 9 minus 9 minus 6x minus x square? What if we write this? Yes, this can help. So this will be root over of 15 minus x plus 3 squared. So this is this particular integral is sine inverse of x plus 3 over root over 15, and we have minus 2 7 minus 6x minus x square minus. Okay, so we have root over 15 over here. If it's not visible, then okay, 5 more to go. 5 more to go. I think I should have practiced the questions because I'm extremely slow actually, and also it is night. It's almost 3 a.m. in the morning. I don't know whether I will be able to sleep tonight or not. 10x 1 plus 10x plus 10 square x dx. So we can just assume that tan x is some t. So dt over dx is t square plus 1. So dx is basically nothing. It's t dt over t square plus 1 times t square plus 1 plus t, which is pretty trivial. Is t square plus t plus 1 minus t square plus 1 over, I'm sorry, so sorry, t square plus t plus 1 minus t square plus 1 over t square plus 1 times t square plus t plus 1 dt. Pretty trivial after this. Is basically dt over t square plus 1 minus the integral dt over t square plus t plus 1. You can actually write it like this. This is nothing but tan inverse t minus, this is 1 over root 3 to tan inverse of this thing, that is t plus half square. You can notice that this thing actually is t plus half whole square. So I'm just trying to form this particular thing. Then we can apply is root 3 by 2 plus c. So this question came in the year 2018. This question came in the year 2018. Okay, so let's move on to question number 22. Okay, question number 22. Integral sine n theta minus sine theta over 1 by n to the power of 1 by n cos theta over sine n plus 1 theta d theta. So we can assume that sine theta is some t. So this is basically dt. This is t to the power of n minus t to the power of 1 by n dt over t to the power of n plus 1. Oh my god, how to do this now? Oh no. Okay. What if we just take out t to the power of n from here? So we'll be having t to the power of 1 minus n and t to the power of n dt, isn't it? Because we have t to the power of n plus 1, and if we take another t from here, and t will cancel out. And now if we take t to the power of 1 minus n as some p, then dp over dt. Okay, instead of doing that, okay, it's fine. So this is basically 1 minus n times t to the power of 1 minus n minus 1. That makes us this. So we have this thing. We just need this thing. So no, never mind. We'll just multiply it. 1 minus n over 1 minus n. N doesn't matter because n is a constant. So 1 by 1 minus n integral. Yes, we can take this also. Then we just have a minus sign. And minus 1. So this thing is PDP because this is P and this entire thing is DP as we can see over here. So this is 1 by n minus 1. Okay, so PDP is P square. So what is P square? 1 minus n square by 2. Now what is T? T is sine theta. 3 more to go. 3 more to go. Question number 23. Integral x to the power 5 e to the power of minus 4x cube dx. Yes, the last question. Last question came in the year 2019. The last question came in the year 2019. And this question is of 2019 as well. Last question came in the year 2019. And this question is 2019 as well. All are JEE mains. So again, we have something in the power. So probably we can do something with this. What we can do? We can assume that this is some t. So dt over dx is minus 12x squared. So what we can do over here? We have x to the power 5. So let's separate the things out. Minus 12x squared times x cube minus 1 by 12. Okay, pretty much understandable. And e to the power of minus 4x cube dx. So this is minus 1 by 12 and yes, we can also do this, but let's try this first. E to the power of t dt. Now we can minus 4 and make it like this. We can make this. Why not? So this thing actually turns out to be t as well. Okay. So now simple by parts. 1 by 48 outside. This is the first function. Got t minus integral to t again dt, because differentiation of this thing is 0. So yeah. Now what is t? T is minus 4x cubed. You can just plug it in here. Two more to go. Please pardon my mistakes. If I'm making a mistake, please do tell me in the comments once I'm done with the streaming. Please do tell me. Integral, question number 24. Integral x plus 1 over root over of 2x minus 1 dx. This came in the year 2019. A lot of questions in 2018 and 19. 2019 has a lot of questions, lot of integration questions. There are almost 1, 2, 3, 4, 5, 6, 7. About 7 questions are there from integration alone. That's amazing. Okay, so what we can do with this? This is actually causing problems. So let's assume that 2x minus 1. Okay, let it be like this. Sum p. So dp over dx is nothing but 2. So dp is 2 dx, or dx is dp by 2. Dx is basically dp by 2. Just a second, just a second. We assume that 2x minus 1 is some p square. So 2 is 2p dp by dx. Okay, okay. So we can deal with this. This is very trivial. This is actually trivial because p dp is basically, okay, wait, just a second. Okay, we need not do anything like this. We can just write it like minus 1 plus 2, because that was because we had x plus 1 in the numerator. 2x minus 1 plus 3, because yes, that's fine. So let's see what we have. Half times half of 2x minus 1 dx plus half of 3 dx over 2x minus 1. Okay, so this is nothing but, we assume that 2x is there, so 1 by 4, and integration of this is 3 by 2, 2x minus 1 power of 3 by 2, 3 by 2 plus 3 by 2 minus half is basically and actually is 4, that should be 4. Yes. I hopefully this is correct. Hopefully, I'm not sure. I don't think there is some calculation problem. Uh, yes, I think everything is more or less fine. It's 3 by 4, and yeah, yes, I guess it's fine. Okay, so we're in the last question. This is also 2019. 25. Cos of natural log of x dx. So what we can do is assume natural log of x as some t and cos of t. Now what is natural log of t? We can just write it as dt over dx as 1 over e to the power t. So dx is basically something like this. Again, by parts, this is the first function, this is the second function. So this is the first function, and that is the second function. Ut. Again by parts, first function, second function. Okay, now you can see that this thing and this thing is basically the same. So this is cos t to the power of t ut is e to the power of t cos t plus sine t to the power of t. Divide the entire thing by 2, and t is basically natural log of x. And we are done for the time being, I guess. And so I think it's time to say good night because it's 3 a.m. in the morning, and I am not even feeling sleepy at this time. I've lost my sleep. I don't know what to do in the rest of the night. Uh, so thank you everyone. For thank you so much everyone who supported me throughout this stream. Thank you so much. Thank you so much. I can't explain how much thankful I'm to you. And I am accepting the fact that I might have made mistakes at particular instances, but please do help me to rectify them. Please do let me know in the comment box that if I've made any mistake, so that I can write those mistakes. I can rectify those mistakes in my description box. I can just rectify them. And if I've made a particular question completely wrong, then I can upload a video um, by saying that the particular question which I had made wrong, I can just redo it and upload the video. So thank you everyone. Thank you so much for supporting me. I know 25 is not a very big number, but yes, it was a long stream and this was my first stream. Thank you so much everyone. So good night, and to everyone who is in my time zone, and goodbye. We will meet soon again. Thank you so much for supporting me.